Beautiful. You know, you mentioned explainable AI. So let me grill you on this term a little more, because we all talk about what the data-driven decisions. We talk about, right, taking company data, taking dark data and make use of it, right? And using the tools, including AI. AI is not the only tool, right? But we
Right?
use many tools there. Tell me about transparency. Tell me about, you know, traceability of the decision made based on the AI analysis and data. Okay, because that bothers us at many levels. Mm-hmm.
That's a great question, because it starts, you know, by what do we mean by explainability? Do we mean regular or regularity? So if it always happens, is that a level of explainability that's sufficient for whatever application that we're working with? Or does explainability mean you can decompose the output into its component parts? And so you really need to be able to pull it apart and say that that decomposition is a fundamental aspect of how I need to be explain the answer that I got. Another aspect of explainability is not only regularity or decomposition, but it's also this aspect of confidence. And I think those three features of explainability kind of capture the majority of where people are talking about it. So in terms of confidence, many models can't tell you when they're confident about an answer, like a recommendation system or in a prediction, because their architecture just doesn't support that. But there are new technologies, particularly in Bayesian probabilistic programming, that give you confidence bounds. And so they have the ability to have more of an engineering style approach in terms of specificity, in terms of their tolerances for the outputs. And you can say, well, look, the model is confident in this answer, or it'll give you an answer, but it's really not confident because of the confidence bounds. So really, it's regularity. Do things happen all the time? Can we break down the answer into its components and get a little bit better of an understanding? Or how can we get a indication of how confident the system is in its output? But it really comes to the way you and I think, right? So if you and I say, well, look, we go to the doctor and we say, Doc, I'm not feeling good. And the doctor says, oh, I think you've got, I need to do a test, but I think you've got diabetes or something. And we say, well, that's an answer. That's a prediction, right? We can do more testing. But how did the doctor come to that answer, right? Or what's the explainability from the doctor, right? The doctor's head is a black box, just like AI is a black box. And we can say, well, look, maybe she has training, and so it's all this history that comes into it, and she says, you know, she can explain why she's giving you the answer, but the answer is going to be the same, right? And so we get to those features and say, look, for different applications, we need different levels of explainability and or visibility and traceability of the answer. Sometimes you don't need an elaborate explanation because the risk is low, right? It's not a mission critical or safety critical application. And so you don't need to overbuild your solution to have a level of detail that it's a perishable item, right? It's not needed. But in other cases where control systems, where you need high level of regularity, you need high level of explainability and that decomposition, so you can see the parts in the system and why they're producing outputs in a chain of events. Then you do need to be able to have an architecture in your system that allows for that. And ultimately, a big part of the explainability from the consumer's point of view, a big part of the explainability comes from the data. So if you have a computer system and the system can be trained in one of two ways in general, super large categories. One is people can put in the instructions and the computer can go through algorithms and spit out an answer. So you know the instructions, and so that's a level of explainability. The second level of ways that the computers can learn is you can give them a bunch of data and some general rules, and they'll learn from that data and they'll spit out answers. The problem with that second alternative is that the data isn't humanly readable. It's too much we can't get our mind around it. And so that's where people are concerned about bias. So if you put in just a bunch of text data from a whole corpus of books, and you start asking questions, then you and I couldn't read all the books. We couldn't read the source material or ingest the raw data, for example. And so we don't have a familiarity with the inputs that are producing the outputs. And that sometimes causes people concern, so and so you say, well, look, does it increase explainability if you have a second layer of of descriptive statistics around the data? So you not only have the recommendation that was produced on the data, but you can have some statistics in terms of the gender pronouns or whatever have you, right? And it gives you an indication as to why the answers were produced that they were, and that might help in some cases too, but really it's right sizing the expectations.
Yeah, it's kind of give us, or I guess managers in charge and executives and leaders in charge, right? It gives some peace of mind that, the output that I got, and I base my next decision, right, based on these predictions and recommendations, right, that I'm more comfortable taking it as a factor, as a decisive factor, right?
Right.
This is absolutely, this is fascinating. And of course, answers, as I'm talking to my guests, month to month, week to week, answers to similar questions change. Okay. That's how fast, reality is changing around us. So absolutely.